real sick, and it was even before they knew what the heck to do or what was going on. It was early. So she got all these prescriptions, none of which worked. She said it, all the classics. Oh, it was awful. Anyway, moving on. So here's the deal. We are obviously wrapping up third quarter. You've probably gotten a billion emails from the county. I put stuff on Blackboard, whatever. And so what I'm accepting still, if something was due the day we got out or a day that week that you were absent, then you can turn that in, and the impact of that would be a curve on the previous test, for which you could not do corrections, but also people did very well, so that will help. The remaining work of quarter three, the quarter ends the 24th. And so what you need to do, if you want that curve, not only do you have to have the work done from before that, but the remaining work actually has to be done and done on time. Not a ton of stuff, you know, we're giving no mark for fourth quarter, but what you do between now and the end of third and what you do for fourth quarter is going to matter. So I'm allowed to, let's say you didn't turn stuff in and it's too late to turn it in, it wasn't the 13th. Well, fourth quarter can still significantly impact your grade. So, for example, if you've done the work, you've done it proficiently, you haven't skipped a bunch of questions, you've gotten most of them right, you've come into office hours, we'll talk about that in a minute, and gotten clarity, then you would get the credit for doing that. And it's just like a check mark, or it'll probably be a number that doesn't matter in the grade book. If you attempted it, so you did most of it, and whatever, I'm not accepting stuff late. It's really crazy between now and the end of the year, so I don't want anything late. If you attempted it, which does not mean, hi, it was a multiple choice and I answered everything C. So you guys know that. But if you made a really good attempt, you got some stuff wrong and you had questions, that's fine. If you totally didn't do it, then you're not going to be eligible for what I'm about to say, which is fourth quarter can impact you because I have the leeway based on your proficiency to raise your grade a half a letter grade for the entire year. So let's say you've got a B, you go, oh my gosh, I really want that extra blah blah GPA point. I'm allowed to raise it to a B+. I can't go above that. So you can't go from a B to an A, you can't go from a C to a B, but you can go up that partial letter grade, B to B+, B+ to A minus, A minus to A, well, I guess that's it. Okay, we do take attendance during class. The county does want to know who's here for class, and the way it's recorded in SIS is VSN, which means virtual session non-participation. And that also goes for people who log in and then they open up another browser, they're on FaceTime, or they're eating pizza and running around the block, and it's clear that they're not answering stuff, or they're not, you know, they're constantly away. You would not get credit for that. So just so you know, you got to be paying attention. These are short classes. You realize that. A once-a-week short class is tough. So if you've got questions about any of this, feel free to wait after class, and I can answer those questions, and that's it. Okay, here we go. So this was the answer that you should have gotten. Yes? Everybody got that answer? I'm sure you did, because most everybody did. Okay, so what we're going to do is go backwards. Partial fraction decomposition means, well, if you think of decompose, it means things falling apart. We're going to make this fall apart. And I want you to watch this. Please don't write anything down. You might be taking notes on a piece of paper. That's phenomenal. But I just want you to watch first. So just like in the previous slide, you had it all, whoa, dude, not that one. You had it all broken up. What we're going to do is factor that denominator, and we're going to write dummy variables, A and B, above that remaining set of fractions. Let me get there. Okay. So here we go. But again, I just want you to watch. You'll have plenty of time to do stuff like this. So the first thing you would do is factor the denominator. So you would say, okay, this is x plus 7 divided by x minus 3, x plus 2. Done. At this point, you rewrite, and I really am not wild about this pen stroke. see if I can make it bigger. Okay, so you rewrite this, but instead of, you know it's going to have to be something over the first factor plus something else over the second factor. And then what you're going to do is eliminate the denominator. So you're going to solve this and work it out and then solve for A and B. So you'll see what I'm talking about here. Also, when you do this, please notice the number of factors in the denominator is going to be the same as the number of fractions that you have. So here I've got 2 factors in the denominator. That's going to give me 2 fractions. If you've got repeated ones, you're going to have 3 fractions, and you'll see how to do this. Okay, so what I'm going to do is grab this whole equation, and I'm going to solve it for A and B. To do that, you can multiply by that common denominator, x minus 3, x plus 2. So when I multiply that, the bottom of this one is gone because that's the same thing. So I got x plus 7 equals, if I multiply the x minus 3, that's canceled from the first one, and I get A, x plus 2. If I multiply this here, the x plus 2's are now gone, and I get B, x minus 3. Okay. And then I'm going to set up equations. So I'm going to take this A and that B, and I'm going to distribute. And you still have an A and a B. Don't fret. It's okay. Keep the left side. So x plus 7 equals AX plus 2A plus BX minus 3B. And then I'm going to put the x's together. So if I put those together, it's going to be A, oh my gosh, this is so hard to write on here. Let me do something here. See if I can make this look a little bit better. Okay, try it now. So AX and BX, well, that's just A plus B times X. 2A and 2B, or sorry, 3B are, what are they called? They're just constants. A and B are constants. So I could say plus, or in this case, 2A minus 3B, that's just some constant, equals x plus 7. Okay, so let me stop and let you digest that for a second. Just think about what happened where we are. Hopefully that gave you some time. If you're still a little confused, we had a lot of these to do. Okay. So here's where we were. So now you line up the coefficients. You say, well, I've got an x here, and I've got an x here. If this equality is really true, that means that A plus B has to be the coefficient 1. So let me write that in. Oh, I need to get a different color. How about this? Okay, so that's 1. That means A plus B is equal to 1. Just write that down and hold on to it. And I know that the constants also have to be the same. So that means that 2A minus 3B must be 7. Look at that. Algebra 1 all over again. How can I eliminate one of those variables? Jane, what can I do to eliminate either A or B? And grab your mic, because this will go more quickly if you use a mic. So just hit your talk button. I don't really need mic. But Jane, if you just hit your talk button.
You could make B equals 1 minus A, and then replace it in the second equation and solve.
Exactly. You could solve for this and put the result back in for B. You could solve this for A, put the result back in for A. Another way that you could do this is multiply one of them by another number and just add. So that's what I'm going to do. I'm really glad you said that, because that is one method that you could do. I could multiply this through by -2, for example, because that's going to give me -2A minus 2B equals -2. The rest of it stays the same. Put those together, I get -5B equals 5, so B equals -1. And then now I can say, well, if B is -1, I can put that back into my A plus B equation. So you would just say, okay, I know systems of equations. So if A plus B is equal to 1, A minus 1 is equal to 1, so A has to equal 2. Put all of that back together, and that means that if I decompose this, I've got 2 over x minus 3 minus 1 over x plus 2, which I believe is exactly what we got. So you would say x plus 7 is the same as, I should have started over here. Where did it go? There we go. 2 over x plus 3, -1 over x plus 2. Okay, so give me some emotion. You understand what I just got through doing? Or your brain has just gotten through waking up and you understand what's going on. Just a little emotion. There's a little emoticon right above your head. Smiley face, confused face. Darby, you came in late, so when we do the next one, hopefully you'll be unconfused. So I see lots of smileys. All right. So decompositions just means I'm breaking something apart. I'm decomposing it. The tree fell and it broke apart and made room for a flower to grow. So first thing you do, if the numerator, so notice this one, well, it doesn't, oh, here we go. The numerator is bigger than the, is smaller than the denominator. That's where you go straight up to here. If the numerator is bigger, you start with long division. And we're going to do one like that. Okay. So that's what this is. And then the rest of what we did is the same. You factor, write the partial fraction with A's and B's, get rid of that denominator, and then put the coefficients together, and then you're going to be solving, usually elimination. Sometimes you have to be really sneaky smart to do these, which you guys are. So let's look at another one. And there are 4 cases. So this is, hi, I have factored it, and I have linear factors only. So x plus 3 and x minus 2. X minus 7 and x plus 5, whatever it is. You just have 2 or 3 factors. It doesn't, oh, just kidding. 2 factors. Actually, you could have 3, and it'll work like that. Repeated linear factors. That's a special one, because you're going to actually have 3 denominators, 1, 2, 3. So 3 fractions, because you've got 3 factors. Non-repeated factors that are quadratic, you're going to start adding in different coefficients up here. So it won't just be A, it'll be AX plus B. We're doing ones like that. And then repeated, irreducible quadratic factors means you're going to do the same thing. You'll have a quadratic, but this time, if it's quadratic in the bottom, it's got to be quadratic for both of those. So this is going to be quadratic. So this is a lot to take in. So let's do an example step by step. And what I'd like to do is cover this. Then you're going to be doing one in groups. All right, so let's look at this. First thing that you do is you factor. So I want you to type in don't hit send yet, but just type in, how does that factor? How would I do that? Just type in your answer, but then don't hit send. Just wait until I want to wait for everybody's little texty box to be lit up. So Jeff, as soon as you're ready, I just need your text box to be lit up. You there, Jeff? Oh, good, good, good. Okay, shoot out that answer to me. Right, +5 minus 2. Okay. All right, so let's put that in there. And I'll pick a different color. Okay. So we've got x plus, whoa, not +5, yes. Oh, yeah, sorry. +5 minus 2. And then you say, okay, well, and I'm going to rewrite it here just so I have room. 5x plus 4, x plus 5, x minus 2. Okay. It's really hard to read, but that's okay. Okay, so I'm going to have a over x plus 5, break them up. And I'm going to use a plus. It might wind up being a minus. I don't know. It doesn't matter. B over x minus 2. You can clear the denominator. So this goes back to how do I solve rational functions like this? So hopefully you remember your algebra 2. I'm multiplying it through by that common denominator, plus 5 and minus 2. That's going to wipe it out on the left, and I get 5x plus 4 equals, this x plus 5 is gone, so you get a x minus 2. And then here the x minus 2's are gone, so you get plus b x plus 5. Did you have a question, Lydia? Because your hand is up.
I was wondering, would it be possible to have like a plus b plus c if the denominator was like x cubed plus whatever?
Yep. Very nice question. You're anticipating where we're going. That's fabulous. So we're doing baby ones, and then we'll do bigger and bigger and bigger until we've got grandpa ones. Nice question. So just hold that question. Fantastic. Okay. So now I'm going to distribute, because I got to get my x's and my constants shared. So I'll keep writing this on this side, 5x plus 4. When I distribute, I'm going to get a x, oh dude, I feel it's annoying. I didn't mean to put the parentheses. It doesn't matter if you do. I like it to look a certain way. Okay, you get ax minus 2a plus bx plus 5b. Put your x's together. This is just a plus bx. Plus, I didn't really have to do that. Let me see if I can just highlight these. So I really meant to say this thing and this thing are going to go together and make up that. Okay, let me go back. Okay, so this is 5b minus 2a. And if you want to put that in parentheses, sometimes it makes it distinct and a little bit more clear. I apologize for my writing. So now I'm going to equate the coefficients. So 5 has to be a plus b. 5b minus 2a. Okay, and I'm going to write those in a way that makes it easier to look at for me. I'm going to write in the opposite direction. Now I'm going to line up the a's and the b's. So if I have 5b minus 2a equals 4, and b plus a equals 5. So that's what I'm going to work with, just so that I have my b's and a's in the same place. Okay. Now I get to solve. Pick your poison. I don't care how you solve it. If you like elimination, that's fantastic. I would not suggest graphing it. That would be a lot of work. It would invite errors. Please, error, come in. So I get 5b equals minus 2a equals 4. And then I got 2b plus 2a equals 5. I want you guys to solve for A and B. Text it, but then don't hit send. Okay, questions, problems, complaints, concerns? So we have decomposed this fraction. It's pretty nice. Okay. Let's see. So what I'm going to do is I'm going to put you in groups of 2. And I want you to solve this. Okay, so just give me 1 second. So we've done breakout rooms before, but just to remind you, what's going to happen is this page will be shot to you in your breakout room on what part you're doing. So name for your work, and then name for the other person's work. And you can break it apart however you want. You do have to be doing something significant, so you can't just say, oh, here's the answer. Okay. Any questions? Questions, problems? Everybody okay? Yes, no, maybe so? I'm guessing you are. So let me, I gotta put you guys into rooms, and then you will see this, and I'll pop in and out. Oh, here we go. I realized maybe I'm on the right, yeah, that was the right example. Okay, so let me know if you are good to go. Just give me a check mark this time because it does persist. So just hit the little check marky thing. So over here, just a little check mark saying, got it, lady, or I'm going to pretend I got it because we want to move on. I'm just kidding. So Tyler, that doesn't surprise me. So I'm not going to go back and reteach it. If you want to hang out, or maybe by the end you'll get it, and or the notes will be posted. Okay. All right. So let's look at what happens if you've got linear factors that are repeated. So when you factor this, that guy is going to be x squared plus 2x plus 1, which itself factors into x plus 1 and x plus 1. So if I were to rewrite this, let's see. I'm so ugly, I just can't stand my writing. Okay. Don't mess with the top. You don't need to mess with the top. Because remember, we're going to be equating the coefficients. So this is really x times x plus 1 squared. So notice this is cubic in the bottom. That means I need 3 fractions. I can't have 2 fractions. I'm adding 3 fractions to get that. So I'm going to put an x, I'm going to put an x plus 1, and you don't want another x plus 1. So think about what is going to go on with this. If I only had one more x plus 1, then I wouldn't get the other factor here. I wouldn't have a cubic in the bottom. So I've got to put that as a square. I got to tell people, well, wait, that got repeated. X plus 1 squared. So when the factor is linear and it's repeated, like this, you got to account for the first one. You got to account for the second one. And you also have to make sure that when I come up with a common denominator, like I'm going to be multiplying that by x, I need to get back to my x cubed. So that's why you're doing this. All right, so let's do this. I've got an A and a B and a C. And I'm going to just like what you did. Multiply through by the common denominator. And if I can make this work. So I'm multiplying by x and x plus 1. And I'm going to put the x plus 1s twice because things are going to cancel. Oh my gosh, that is so ugly. Okay. So when I multiply all of this stuff by the bottom, this is gone. That was the whole point. I can get a different color. It's annoying to me. Okay. So on the top, just like before, you get 3x squared, 12x, 4. Here I'm going to have a times x plus 1, and there are 2 of them. B x plus 1. And then this is going to be just cx. Okay? Now you can do this 2 different ways. So I'm going to do this problem 2 different ways. The way that you did it before is totally fine. So let's take a look at that. And then I'm going to show you a sneaky smart way to do things that sometimes can eliminate a lot of work. So you would have 3x squared, 12x, 4. This is going to give me ax squared plus 2ax plus 1 plus b. I hope you see it. Jay, what's up?
So when you have A, B, and C, why is there a BX and an X plus 1?
Bx squared plus bx times 1?
Yeah.
Did I do something totally weird with this one? Or maybe I did something weird right here. Let me just, ax squared, hold on 1 second. That's why I was stopping, because there's something weird about what I did, and I did too much in my head. As usual, this would have been x squared plus 2x plus 1, and then with the a. So just hold on 1 second, just let me noodle it in my head. Ax squared, 2ax, a, bx squared, bx, cx. Okay, so then I'm not seeing what I did.
Squared plus 1 squared plus B plus x plus 1. Why is it B x times x plus 1?
Because
it's bx x plus 1 plus 1.
Well, this x is still there, no? If I multiply that by x plus 1 and x plus 1, one of those is gone, but then I've got that. So I still feel like I did something weird, and I don't know what it is, and I just hold on 1 second. Okay, here it is. I'm going to put these together. So my x squared, so ax squared and bx squared is just a plus b x squared. 2ax and bx and cx is going to be plus 2 then plus a. Isn't this a pain? I can't wait to show you the other way to do it. Okay. So this means I know a immediately. I'm going to go with the stuff that I know really fast. So a is equal to 4. If a plus b is equal to 3, let me just do this. A plus b is equal to 3. Well, I just figured out a. So that means 3, a plus b. I know a is 4. So b has to be -1. Maybe this isn't so bad. And then I can set the, let me see if I can come up with a better rectangle. Okay. Then I can say, oh, here is 4. And here is my constant. Set those guys equal to each other. A is 4. It should have been 12. Thank you so much.
Okay. So
Didn't need to know that. Yeah. No, you're fine. That was me being weird. It should have been 12 because it was the coefficient of x. I want to show you a way to do it that is really sneaky smart. Now, you don't have to do this. It's not that brutal for what you're doing. So you start off the exact same way, and then you get this. Now, check this out. If I just, because I can do anything that I want, as long as I'm doing it to both equations. So what I can do is I could substitute a -1 in for x. What would happen if I substitute a -1 in for all of these x's? Why is it 2ax? Hopefully I just saw your text late, Andy. I'm not sure. Oh, I did see it late. Okay, sorry. Okay. So let's say I made x equal to -1, just for kicks. If x is -1, then, people are saying weird stuff. It looks like people are texting. I just want to make sure that you're okay with this. So if I let x equal to -1, then a and b are gone. This is just -3, -12, +4, and then this is just c. So watch this. I can eliminate everything else and get c equals 5. Then I continue back solving. If I say x is 0, why wouldn't it be -c? It is, but then that's -5. So then it's just plain old c. Yeah. Then I can say, okay, I know c is 5. I'm going to put that in there, hold that onto that. Then I can come back here and say, well, what if x is 0? Well, that's kind of nice. I just get 4 equals a. All of this stuff winds up just being 4. You don't have to do this. If you like to equate the numerators, that's fine. Then I can say, hey, I'm going to make x equal 1. Solve for b, put it back together. So you can be sneaky smart with this. I don't want to take tons of time on it, because it's just a different way to go. This is actually what I do because I get annoyed like multiplying stuff out. So this screen, you'll have access to this, and then you can go back and look at it. We don't have much time. What I'd like to do is this would probably be a really good one to do. And then the rest of this is just going to have to be online. So check out what happens. This is not linear anymore. This is quadratic. And it's not reducible. It's not like I can factor it or anything. So when I write this up, I'm going to have ax plus b times x squared plus 1, and then cx plus d for x squared plus 1 squared. So that part works the same way. The squared part, you have one of them, and then you've got two of them. Because if I didn't, I wouldn't get this back again. And I know I need 4 variables. I need 1, 2, 3, 4. So I need 4 coefficients. So I've got 1, 2, 3, 4. I've got an A and a B and a C and a D. Let me keep on going. I don't want to take the time to me actually go through it, like step by step and have my nasty writing. I'd rather just show you what I have from before. So your basic equation looks like that. So what happened here is I multiplied through by the common denominator. So that wipes it out here. One of them is gone here, so I still have the x squared plus 1. And then the entire denominator is gone. So you get this equation. So now you're welcome to multiply. It's not a bad thing, actually, just to multiply out this stuff and that stuff and equate the coefficients. To most people, that makes the most sense. That's what this is. Which is how this one was done. It's not that you can do it. Oh, I guess you can't do it the sneaky smart way. Because whatever you plug in is going to cancel everybody. Evaluate the coefficients. None of the rest of this is different. Your whole partial fraction thing looks like that. And notice again, Darby's question was so excellent. Had I just done an x squared plus 1 and I hadn't had the square, when I multiply those back together, I'm not going to get the cube. So if this had only been a 1, pretend that's a 1, then I wouldn't get back to where I was. So repeated irreducible quadratics, that's something that you'll be doing. I'm just going to flip through here because we're actually finished time-wise. I just want you to see one more thing, and that's this. So the big difference, notice this is x squared on the bottom. That's cool. This is also x squared on the top. We have not had that. We've always had the bottom 1 degree bigger. So if the bottom is equal to or greater, if it's equal to or the top is greater than, you have to start with long division. Because I want the top and the bottom to have a ratio of the top being 1 less than the bottom. So first thing I'm going to do is long divide. You remember long division. This can only be done with long division. So I say the bottom into the top yields 2 plus that thing. Now I decompose this. Leave the 2 there. Bring the 2 into your final answer. But you set up your coefficients. That's actually your final answer. Let me get rid of this. Everything's hiding under here. Fortunately, it's already done. Notice these are just linear factors. When you get to here, this is x times x minus 1. So there's nothing fancy about that for this part. No repeated linear anything. So the rest of it works the same way. You just have to remember that you've got that 2 on the front. Oh my gosh. It's freaky. But the rest of it you solve it the exact same way. No different. You just have to remember to stick that 2 on the front. So this 2 comes from here. The rest of it and everybody else works the same. All right, and let me, same story with, I think this might be the last one. Yes, it is, because then this starts to repeat. Okay. So the same thing happens here, and I'm going to cover this up just so you can sort of see it step by step. Please don't try to write this really fast. It's going to be torturous because I'm going too fast for you to write it down. Okay, so notice the bottom is smaller than the top. Start it with long division, because then you'll knock out a bunch of stuff, and you'll only have quadratic on the top. So here's the story. So there's my long division. Sorry about how light this is. And so once you've done that, you wind up with, oh, what do you wind up with? There it is. So this thing just comes into your answer. I feel like I'm missing part of this. Let's see. There it is. So this one, the rest of it, you can finish this. So it's going to be this stuff plus, let me just write it. It just didn't get finished. So it would be x squared plus x plus 5 plus negative 1 over x plus 12 over x minus 4. So that is your final answer. So the only difference again is the bottom had a degree that's smaller than the top. Start out with long division. Keep this part in your answer. That's just the first part of your answer. Everybody else works the same way. Okay, so let me get some emotion, smiley face. I got this. I can't wait to go outside and play in the cold weather. It's so cold. So Nikki, if you want to stay for the next class, the other classes today are canceled. You realize that? All of your other classes are canceled today because people are, I also sent out a thing. I'm outside of the system for this classroom, so it doesn't matter to me teaching-wise. But other people can't do it because they're relying on Blackboard Ultra, which I'm not even doing that. So I can keep on going, which is good for you. I know you might go, I'm not class. Okay. All right. All right. I'm just saving the participant list for this so I know who I'm giving credit to. All right. All right. Okay. So I'm going to stop recording. What other periods? Just this one. Just period 4. So I'm only, okay, hold on. Let me quit the recording. People don't need to know this stuff. Recording started.